Assalamualaikum warahmatullahi wabarakatuh. My name is Roslan bin Tariq, together with the co-author Muhammad Zailan Suleiman from University Science Malaysia, School of Housing, Building and Planning, Pulau Pinang, Malaysia. This is the paper for this ICWS AUD 2020. Okay, this paper is entitled Why Building Defects Still Happening in Malaysia. Okay, now I'll start with the abstract of the paper, which is the purpose of writing this paper is to explore on the pilot testing survey on building defects problem, focusing on the leakage defects. Okay, 9 research questionnaires categories has been developed, and for this paper, 3 of the questionnaire has been selected and be analyzed with the SPSS version 34, and the research approach using the existing research flowchart developed by, I think, the easiest to understand or the flow, which is by the local statisticians, with the background of the Qualitative Research Methodology. Okay, the research methodology using the, however, using the qualitative approach, which is more suitable for the project scope and the objective. Okay, the next part on the paper is the introduction. Again, this paper focusing on the most common defects in Malaysia, which is, I think, the BLD, the building leakage defects. Okay, leakage defects require special attention among the industry player, the construction players, and strategies must be drawn on how to overcome or minimize this defect systematically. Okay. In general, the defect occur maybe from poor design, not a quality workmanship. Okay. The building constructed not according to plan, and there's many factors. Design factors, as mentioned by the National Building Agency. Okay, so these primary causes may operate uh, in the combination of the results, indicate of the maybe the changes of the composition of the material, the construction itself, blah blah blah. As far as the literature research mentions that there are a lot of things to be learned from the history of the building with the roofscape of the old buildings, and the primary defects likely to be found either to the top, to the roof, or to the bottom, meaning that from uh, the below or the floor level, the water can raise up, or from the rooftop. So great care should be exercised when we are talking about structure materials within the roof. Now, this is the research flowchart that I use. Local academicians quite recently in 2006. You can focus on the blue part, or or the rendered one, and even the green. Start with the start there, and the problem formulations, and we theoretical and conceptual model. We come up with that, and survey fieldwork, finalize the questionnaire, and then we do the pilot testing from here, and get the expert opinion, and then we proceed if yes, and then we go to prepare the draft report after we identify the site case, the case studies, product observations, and then this will have on the final exercise, final survey, but we run the pilot test first. Okay. Now, we also, what I'm saying is that both of us come up with this sort of like graphic manipulation, represent the representing of the basic building construction process, started from the design, the product, and the post-construction. The design, from the layout, the detail, the design clarity, all this potential of generating the defects, all the specifications, the weather friendly, even the green maybe should be here, and the post-construction, including the fire safety factor, the workmanship, maintenance, and the usage of the space that we design. Is it according to the design, or the use of the space not according to the design? Okay, now, so this is the schedule or the table that I formulated on the questionnaire targeted to the industry players for the pilot testing. Before we finalize the exercise, the survey, we come up with the pilot testing first, whether the formula is in order or not. So I formulate about 9 variables here. Okay. Concerning the affected internal area, what's the value of the damage, where the source of the leakage, the effects criteria, the material use in solving the leakage problem, the defects problem, what recommendations, future recommendations, and anything that you want, the participant want to share. Now, for this paper, only questionnaire number 3, 4, and 5 has been proposed, because I think this is appropriate for this paper. So I just select questionnaire number 3, 4, and 5. Number 1 and 2 already elaborated in the earlier article, different article, due to the limitation original. So Q3, Q4, and Q5 will be tested with the statistics formula. Whether it's yes or no, to fit or not fit to the theory. So for questionnaire 3 and 5, as well as the Q1 and Q2, all the respondents highlighted here based on the job from 5,000 to 50,000, 51 to 500,000, or even to 500 and 1,000 to 1 million or more than 1 million. Has been categorized as that. Okay. So all the acquired data were filed within the 10 years period from around circa 2009 until 2019, involving real on-site waterproofing related projects. Okay, this waterproofing related projects occurred with a lot of problem, a lot of defects to be studied. So we assume on the BLD, on the leakage of this waterproofing system, whether it's in the roof, from the wall, or from the floor. And either this defect is latent or non-latent, which will have to be rectified and have to have a good technique to do the correction. Okay, now a total of 21 respondents. You can see from the chart here that we have for the pilot test, I think 21 people who involved in this industry is good enough for me, and with the consent of the supervisor, then I think for the pilot test, we can give a good impact to the real study later on. We have a range of people, from project managers, either from engineering or architecture, main contractor, WSC, quite important here, waterproofing specialist contractor, which is the highest in the list here, which is 6. 3 in Penang, 1 in Klang Valley, and 2 in Kuala Lumpur. And we have also the interior designer, interior architects, registered architects, site supervisor, facility managers, and so on. You can take a look at the list there. Okay. We have 3 tables to be studied here from that 3 questionnaires. Okay. So the 3 tables here, this is the first table, table number 3 from the paper. Okay. And we use the version 24, okay, of the SPSS. It's analyzed on the BLD sources, building leakage defect sources. Okay, so here we got SD, standard deviation, the mean, the variance, and the skewness. You can take a look here. This is the N is 21, which is the 21 people who involve it. Okay, so we will talk about the statistics later on, how is have a meaning to the BLD sources. Okay, the idea of this statistics test is to determine which internal and external space has been had the most impact of the defects. So it seems like it's focusing more on the BLD, okay, which is the intention of the study. Most of the respondents understand that the rainwater is a problem here. Dam rising, which is from the water, high water tables, water problem, and so on. So for the SD statistics, the space that's having a roof, using roofing tiling system, had the most number, which is 2.32174, indicated that this space was having the most source of defect problem on the building leakage. Okay, so the SD analysis stated that the space that having a roof, using a roof tiling system, roof tile, this SD indicate that the higher the SD mean, the number of the spread out, while the lower, less than lower SD implies that most of the number are close to the average. Okay. Number 2, there's a score of 2.28, okay, and which is on the water tank part of the building. Okay. And we take a look here that the water tank part, which is sorry, this is water tank is number 3 with a 2.22. Okay. with the metal roofing is a number 2, using the metal roofing problem. Yeah, that led to water defects. Yeah, we had mentioned before that 2.28. Okay, so we know, which part of the roof that we got most of the problem for the 21 industry players survey, online survey that, and then we put in the statistics, the SPSS, and it's indicate from the respondent of the online respondents, the SD implies that this is the what is the area, what material is from these 21 people experience letting the water have give impact to the defects of the building. Okay. Here, just want to make it quick here that the space, mostly for the roofing part, especially on the roof part, okay, having quite a problem with the leakage defects. So most of these upper floor, especially on the just below the roof, having located the CEO office, a penthouse, which is among the top on the top of the building, having the most problem. The location to the top. Okay. Okay. Now, this is on the mean. X, it is equal to 4.333. The mean, you can take a look at the table 3 in the report, which is again the most problematic part of the building component, which is metal roofing. Okay, I have quite a big problem from the experience of the 21 people. And number 2 is 3.95 feet on the external wall, while this tiling roof tile is on number 3 with 2.7619. Okay, so this statistics indicated that these 21 people in the industry mentioning that somehow metal roofing is they're giving the big mess. Next is the roof tile, and then the last one is the external wall. So you can take a look in the report later on, and the skewness statistics also somehow prove that the leakage sources from the water piping, from the aircon water piping, and the CFR. This is very important, the CFR, concrete flat roof, especially within the internal space of the structure, as these 3 parts rated the highest in the skewness statistic. You can take a look. So of the table 3, then this is the analysis indicated that which part is the most problematic from this pilot test survey. Now we moving to the next, the second of the third table, with the table 4, which is same statistics software, SPSS version 24, provided by USM. Is on the analysis of the BLD criteria factor. Okay, we have here about, I think about 9 variables here for the design factor, poor details, wrong method, wrong material. You can read through here until the last one, which is the wrong usage of the space. And we have 21 people in the industry, n equal 21. Then we have here the mean and the SD again. I'm sorry, it's 11. Okay, 11 levels. The result of the qualitative unstructured interview done. Okay, where more of the internal space has been identified for the analysis. Okay, it could be from the interviews, unstructured interviews done here. Okay, so let's see what is the result here of the 21 people in the industry, from project managers to the architects to the interior architects. Seems like the standard deviations found that is lack of use of innovative material to the SD equal 1.34164. Lacking of maintenance, number 2, SD equal 1.3727. And it's ranking on the number 3. Okay, so there's position there. Okay, so while the problem seems to be emphasized on the defect criteria with the lowest ranking goes to the wrong method. The lowest ranking goes to the wrong method or wrong rectification work system to overcome the problem. And we have here the less experienced WSC, waterproofing specialist contractor, less experience. So they use a wrong method, a wrong rectification system. Okay, and there's not creative input to tackle the leakage detail design. So the BLD, the defects, the building defects, mostly from the water seepage. It's been repeating and been repeating and been repeating for generally between 6 to 12 period only. It's been repeating. It should be more, I think, for the warranty. Okay. Accident intervention solutions should come out with 3 to 5 years before it fails again. Not 6 to 12 months. Okay. It should be 3 to 5. It is useful to stress out that in the US, BLD with latent time receive 5 to 3 years, even longer. Okay. I mean, like above the same as previously, but it's quite a reasonable period warranty, according to the building contract. Still referring to the table 4, the next column shows the mean. And I just want to read what's this most of the problems here. It's got this defect criteria is on the wrong usage of space, meaning that the space designed for office they use for kitchen, for other stuff which is heavy use. Okay, it should be lower usage than the wrong use of the space and give a lot of defects. Okay, and then the number 3 is with the mean of 3.5714 on the fire hazardous factor. I mean, like they have defects due to fire. Okay, like the fire extinguisher not working, things like that. So it's not working. Using the not a fire retardant material for the interior, that's also considered the defects from the survey. Okay. Now, this is the table 5. This is the third table, which is also the last table to be discussed in this short paper. Again, using the SPSS question 24 to analyze on the BLD material and part usage used to solve the leakage. Okay, so we have here the it started from the coating layers, cementitious lipid chemical, pure gratting, fiber, EPDM, V-growth, water plug, PU, liquid membrane, silicone, acrylic polymer, the bituminous membrane is the last one, also involving 21 people. Okay, this is the material especially these waterproofing materials. I consider it like BLD, building leakage defects, yeah, coordinated from mostly from the water. And it shows here the main, yeah, and the SD, and also again the skewness. From the statistics computation, it seems like that the BWM, the bituminous waterproofing membrane, the typical material that cover up the roof part, especially on the CFR, hold the most problematic material use, eh, with this SD score of 1.932. So wow, this is like quite shocking, like this BWM, a typical material being used in Malaysia. Okay, mostly I think it's imported materials. Yeah, definitely it's mostly it's a bit imported. Yeah? Still having a lot of problem. So it must be could be the technique of install it. Maybe wrong technique. Maybe when they install it, yeah, the weather is not that hot after the raining. It's not really dry, and then they proceed. Very poor lapping and things like that. This is need to identify. Okay. For example, here, even I mentioned is here, one of the materials from France, like Exter here, which is have distributed in Malaysia. But the thing is, from my experience, this is how the applicator applied to the flat roof, especially, and the lapping, and this one, it meets the corner, it meets the wall of the on the rooftop. How's the detail like, and things like that. Okay, so it's quite important that experienced WAC have a good experience to apply the material. So like the highest scores here. So maintaining the 21 people, that in table 5, 11 labels, level 11 variables, result from the qualitative unstructured interview again. Okay, for this one, it's found out the CLC, cementitious liquid. The one like the BWM is like a membrane. This one like a liquid membrane. Okay, this one is hard membrane. This is liquid membrane. With the SD score is 1.886. Okay, so it's also something shocking to me, meaning that both type of this EPDM roofing materials giving impact to the defects, especially the BLD, either is solid or is in liquid. So it's something wrong with the application. For the statistic here, I think there's something wrong with the application. I think I should make a sub question to that. Okay. Still referring to table 5, the mean we rating, which is 6.046, 0476, concerning on the PU, polyurethane grouting injection technique, impact is the most problematic material to solve these defects. Okay, I think this is quite true because when you have leaking defects, most of the WAC like to apply PU, which is to me is just like a temporary measure. After like it's not properly done, 6 months or 3 months, it will leak again. And this is a typical solution. Whenever they have a leakage on the slab, concrete slab, this is the PU, injecting grouting, PU grouting. Then 3 months, if like in December, more raining, and it's less. I mean, like 6 months. If in December, monsoon seasons, especially on the even though on the western coast from the Malay Peninsula, still have problem. Not even 6 months. I would expect, like, if not properly installed, like 3 months. And this is a big deal here. But somehow this developer or the government-owned buildings, the project management company that represent the government overlook it of this PU technique, to solve a short-term problem. Okay, and we got here the skewness, symmetrical distributions, over here, which is the variables. Consider the V growth with the polymer modified mortar for the concrete usage of the BWM, and the material called multi-layer coating is have value of negative 1.4, negative 0.34, negative 0.39, and this is all the material that need to be noticed, as per table 5 in the report. Now, this is like the end part of the report. To summarize the statistics analysis with the 31 respondents, that the statistics shows that most of the mentioned buildings component facing severe building leakage. We mean the building component in the roof part, the wall part, all the four walls, the basic building, and the floor, which is the lower part of the components, have all having a problem there. So only focusing on the waterproofing defects of the building component will still defects happen to other area focusing on other defects criteria. Building interior element can be considered among essential part of the building. People spend, yes, and this is true. People spend 80% of their time inside the building rather than outside. Okay, so it's quite important that the way how we treat the building defects is important, because we don't want to stay inside the building and the rain water right above our head. And we have a total of identified buildings defect related to the component of the categories using 5 to 7 leakage scale measurements. You can see those 3 tables, and indicated even the pilot testing state at least 80% listed the variables, deep, mentioning a deep problematic, deep problem, range addressing with the BLD, LDS symptom, building defects, building defect system, symptom, okay, and the total of the sum of 37 variables show 90% of the defected interior space is defect. 90% of it the interior, where the descriptive statistic analysis study leading so that 70% found leaking defect from the total 15 categories on leakage sources and 11 classes of defects criteria factor. Next on this conclusion part is that the leakage defects play a tricky game, as sometimes you can see the fault with naked eyes, sometimes it's not. Meaning that sometimes it's latent, sometimes it's non-latent defect games. It's just like currently this COVID-19. This is a latent defects. You cannot see it. You cannot see this COVID-19, what you call it, this virus. You cannot see it. Just effect to the people. People died. Same thing with the defects. You cannot see it. It's a latent defects. You cannot see the naked eyes. So people think that external labeling might look awesome, the external must look good, and but they spend more time to develop how the internal space been bombarded with all kind of defects, comments, from all angles. Yeah? This require change of mindset, of this industry player. Okay, you can read through that, like the wet areas in the buildings getting a lot of problems. So I think from the survey of the 21 active contributing the contribution to this sector, the Likert scale, interviews and so on, with the main SD and questionnaire execution analysis result on about 1,000 building defects, from the systematic of 15 building parts, the building components, especially on the roofing. Okay, now, okay, the last part on this conclusion is that the next phase of the study is to refine this pilot test and then refine the refinement on the further studies. We give more comprehensive structure of the survey, of the real survey, on the, either we do it in the mixed mode, the quantitative or qualitative approach of it, and fine tuning the conceptual model, fine tuning the RQ or RO, or even the hypothesis, as Schneider mentioned it in this book in 1994. Okay, and urge to view what is the knowledge required, to all the industry players, especially like property managers, WAC, in tackling the real defects. So we hope that from that three level analysis and the selected questionnaire from that particularly 9 variables, survey with the pilot test approach, I think is pilot test is very important to fine tuning and to direct which direction of the real survey, real research of this particular topic to be done later on. So with that, I thank you for your listening part in this conference. I hope this paper can contribute at least to these industries. Then I think I will convert it in YouTube. You can see it in YouTube also. And you can, if you have a question, since we have just online conference here, mail me, or I hope how my online from my village here is okay to answer your question. Thank you very much. Assalamualaikum. Thank you. Bye bye.